What is web encryption and how does it make the internet more secure? That's what I'll be covering in this video. I'm going to cover what web encryption is, covering the terminology of SSL, TLS and HTTPS, and a short explanation of how it uses hybrid cryptography for performance reasons. Then look at how important it really is. Does it matter if a website doesn't use encryption? Does it mean a website with encryption is secure? As a heads up, I don't think encryption is always required, although it does provide additional protection. And just as important is to be aware that just because a website has encryption does not mean it's safe. I'll then finish by giving a quick overview of different types of certificates available, particularly useful if you're looking for CISP certification, as you're expected to know about these. Web encryption can be important to help protect users on the internet. Without encryption, messages sent between you and a website could be intercepted and read. Encryption takes the data that is exchanged and converts it into a form that can only be understood by your web client and the web server you're communicating with. We call this the cipher text. I've covered this on earlier videos about encryption. Whilst the internet might have a bit of a bad reputation anyway, without encryption the internet would be much less secure and certainly not somewhere you'd want to do banking or enter your credit card details. So you may have heard of the terms SSL, TLS or HTTPS. What's the difference? Well, nowadays there isn't any, or at least in the way the terms are used. So first, SSL. It refers to Secure Sockets Layer. It was the original encryption used for web pages. It is now depreciated, but is so ingrained in the language of the internet that people still refer to SSL when they actually mean TLS. So TLS is the replacement for SSL. It stands for Transport Layer Security. Version 1 came after SSL version 3, and it is the encryption technology used today. The current version is 1.3. HTTPS stands for Hypertext Transfer Protocol Secure. It's basically HTTP, which is the protocol used for transferring web pages, with added encryption. The encryption could be SSL or TLS, but these days it should be TLS. HTTPS uses port 443 rather than port 80, which is the default for non-encrypted web traffic. These are all terms with specific meanings, but are commonly used interchangeably. In fact, my hosting provider, along with many others, still refers to SSL certificates when they really mean TLS. TLS uses both asymmetric and symmetric encryption, which is why it's often known as hybrid encryption. I won't go into detail into asymmetric versus symmetric encryption, as I've already done that in my other videos. Essentially, asymmetric encryption uses the private and public keys for the web server and the client to set up a secure session. However, asymmetric encryption is slow, so the client then creates a symmetric key, which is encrypted using the server's public key and sent to the server. Then, when the client and server both have a copy of the symmetric key, they use that instead, which uses less processing and is faster. To do this, they use what's known as a TLS handshake. So first the normal TCP handshake is performed. Then the client sends a client hello to the server. The server responds back to the client with the server hello, which sends their certificate. The client sends a symmetric key that it's generated and a change cipher spec request to the server. The server responds to the client confirming it's accepted the new symmetric key and that it's changed cipher. Then from this point on, the client and server use symmetric key for all their traffic. I'm going to look at why we use TLS, looking at three different aspects that we want to protect. Protecting user logins, protecting data, and protecting privacy. The importance of these depends upon the website you're visiting. but it can create a false sense of security, something I'll look at later in this video when I look at the different kinds of certificates. I'm going to put myself in the mindset of a malicious user who is trying to steal information, sometimes, perhaps incorrectly, known as a hacker. At this point, I will say that I've been running websites for many years without any form of encryption. I've now moved to a new hosting provider, which has allowed me to enable TLS on all my websites. Whilst it's important for some of my sites, for others the extra security provided is limited. It was, however, one of the main reasons for me changing hosting provider, as I wanted one that would provide web encryption. Clearly it's important to protect user logins, otherwise someone can impersonate you and potentially do some damage. This could be defacing your website, or if it's a bank, they could set up unauthorized payments. Even for less important sites, login information can be used to access your profile and potentially obtain your email address or similar. Again, I've created a video which shows how you can use the Wireshark tool to steal plain text passwords. How easy it is to capture that depends upon the networks that the data traverses. For a hacker, unless they have access to parts of the network where the network is routed, usually restricted to network engineers for communication companies or data center providers, then you need to find a place with weaker security. But one way that they can try and steal data is to set up a fake wireless network, perhaps at a motorway service station, coffee shop, or public transport location. The attacker then sets up a device that forwards the request on, but also captures the data looking for passwords. The user comes along not realizing that the name of the SSID is for somebody that's trying to steal their data rather than for an official service provider. And this is something that web encryption can protect against. Encryption is clearly important for protecting logins where used, but some of my websites don't use logins or rely on other methods for authentication, such as non-web-based protocols. In that case, do they still need encryption? Well, keep watching. When thinking of protecting the data, you can look at data that the user submits, as well as data the user receives. The first is fairly obvious. You don't want any credit card details that you submit to a website to be stolen. But none of my websites ask for direct payments, or if I did, I could just pass on to a merchant website or similar. But what about data from the website to the user? It's mostly public data, so there's no point in stealing it across the network when you can just visit my website. But what if that data could be manipulated? A man-in-the-middle attack is where the attacker intercepts the messages and then they can manipulate the data before sending it on. Perhaps inserting a malicious script or manipulate links inside the website so they go to a different website. This is something that web encryption does protect against. The final thing I'll cover is about privacy. I don't think it matters much in the case of my websites, but web encryption can provide some element of privacy to the user. I'm not talking about privacy of submitted data, I've already covered that. Just whether someone can track what sites you visit and what you do on those sites. It's only limited though. By monitoring the traffic, it's still possible to see what websites you have visited, just not which pages of those websites. It's also possible for the owner of the web server to see what pages you visited, and your computer history may still record that information, unless you're in incognito mode. If you want privacy when visiting a website, there are other ways of achieving that, such as using the Tor browser. Even then, you still need to be careful what you enter to not give yourself away. So here's a quick summary. It is very important to protect any user logins, if you have them. Not all websites use that, and so it's not always a requirement. You do need encryption to protect data that is submitted by users, but it's also useful to ensure that nobody has tampered with the information sent to the user. It's harder to exploit that, but can be another benefit of using TLS. Then protecting privacy can have some benefit, but only little. It doesn't hide the website visited, and the web server can still see everyone that requests information. There is one negative aspect to encryption, although it's not a fault of the encryption, and neither is it a reason to not use encryption. The problem is, how do you know a certificate belongs to the company you think it does? Could encryption and a certificate make users think that a bad website is one that can be trusted, provide a false sense of security? Google thinks so, and is planning to drop the padlock icon from Google Chrome later this year. The reason is that many people believe that the padlock indicates that you're on a good website, whereas all it really means is that the data between the client and the server is encrypted. It doesn't mean that the server is safe. Because of this, the Google Chrome browser are planning to replace the padlock with this tune symbol, which allows you to click through to find out more about the security of the website. Which brings me on to details of the different types of certificates. The most basic certificate is the domain validated certificate. This checks that the applicant has the right to use the specific domain name, but there is no checking that the company even exists, or checking that they are not trying to impersonate a different company. These are the types of certificates issued by many hosting companies and the free certificate providers like Let's Encrypt. If someone registers a domain name that tries to impersonate a different domain name, such as by adding extra characters or swapping similar characters, then they will still show as valid and can still have that padlock symbol. For an organisation validated certificate, in addition to checking the right to use the domain name, the certificate authority also conducts some vetting of the organisation, and this will add the organisation name in the certificate. For an extended validated certificate, then the certificate authority also performs the vetting of the organisation, including checking the legal existence and that the identity matches official records. In summary, web encryption through TLS is an important way to make web browsing safer. It's particularly important if the user is submitting information such as logins and especially credit card details. Whilst less of a concern for some other websites, it still helps to ensure that the data that the user receives is the same as what was sent by the web server and hasn't been altered en route. Final warning, just because a website uses encryption and has a padlock icon doesn't mean it's the website you intended to visit, and it doesn't mean it's a safe website. Thanks for watching. If you learned something from this, then please give it a thumbs up. If you haven't already subscribed, then please do that so you don't miss any of my future videos.